Good day, good day, good day, future engineers. For today's video, magdi-discuss tayo ulit ng another situation from the April 2025 CEBoard exam. This time, mixture problem. So the problem goes, the basic proportioning trial batches for normal weight concrete with an average compressive strength of 32 megapascals at 28 days are as follows. So, given tayo ng properties ng trial batches. We have the slump, water cement ratio, specific gravity of cement, specific gravity of fine aggregates, specific gravity of coarse aggregates, water, net mixing. This means that 180 kilogram per cubic meter of concrete. Okay? Hindi ito yung unit weight ng water. Baka ma-mistake kayo. You will consider this one as the unit weight of water. Remember, unit weight of water is 1,000 kilogram per cubic meters. This one, 180 kilogram per cubic meter of concrete. Next, we have unit weight of dry rotted aggregates, 11.2 kilonewton per cubic meter of concrete. Now, hindi siya specified directly sa problem, but for the analysis, you must take into account per cubic meter of concrete. Hindi ito yung unit weight ng dry or unit weight ng coarse aggregate. Okay? Next is concrete unit weight. Alam naman natin ito, 24 kilonewton per cubic meter. Now, in this problem, well, hindi na-specify or wala na-specify yung volume ng concrete. So take note, if it is not specified, assume 1 cubic meter of concrete. So I will state here, we call it. Let's proceed to answer number one. Determine the volume of coarse aggregate. Now, to solve for the volume of coarse aggregate, we must go back to the general concept of solving for volume using the unit weight. We know that the unit weight of the material is simply equal to its weight all over the volume. Now, to solve for the volume, that is simply the weight all over the unit weight. Here, we are given the unit weight of dry rotted aggregates, which is per cubic meter of concrete. Now, if we assume 1 cubic meter of concrete, we can now solve for the weight of the dry rotted aggregates, or that is your coarse aggregates. So let us specify that is weight Ca for coarse aggregates, which is equal to 11.2 kilonewton per cubic meter of concrete. And we will multiply 1 cubic meter of concrete. So the weight of the coarse aggregate is 11.2 kilonewton. Now, how about the unit weight? We are given the specific gravity of the coarse aggregates, 2.68. Diba? The unit weight of the material is simply equal to the specific gravity of the material times the unit weight of water. This concept came from specific gravity. Specific gravity is the ratio of the unit weight of a material over the unit weight of water. And multiplying water, unit weight of water to the other side, you will now have this formula. Okay, with this, we can now solve for the volume. The volume of the coarse aggregates, that is 11.2 kilonewtons. Then we have 2.68 yung specific gravity. Then 9.81 kilonewton per cubic meters. So cancel out yung kilonewton, cubic meters lang yung matitira, and matransfer siya on the numerator. So the answer here is 0.426. Next question. Determine the volume of cement. Okay. Same concept, tulad ng kanina. We have a volume that is weight all over unit weight. Now, paano natin ma-solve yung weight ng cement? So you can notice, in our given, meron tayong water-cement ratio. Water-cement ratio is simply the ratio of the weight of water all over the weight of cement. Take note, yung weight of water, nasa numerator siya. You can base that here. Water, meaning sa numerator, and cement, eto, the last one, sa denominator. So, water-cement ratio, this is the formula, and we can solve for the weight of cement. That is weight of water all over 0.62. Right? How do we solve for weight of water? Using this one. We are given the net mixing of the water. Weight of water, that is equal to 180 kilogram per cubic meter of concrete. So we multiply this by 1 cubic meter. This is equal to 180 kilograms. And we can now solve for the weight of cement. Weight of cement, that is 180 kilograms all over 0.62. The answer is how much? 290.32 kilograms. And we can now solve for the volume. But as you can notice, our unit is in kilograms. So instead of unit weight, we can use density. Volume is equal to mass. This is in kilograms. So magiging mass na siya. Mass all over density. And same concept. The density of a material is simply equal to the density of water multiplied by the specific gravity of the material. Therefore, volume, that is 290.32 kilograms all over unit density of water, 1,000 kilogram per cubic meter multiplied by the specific gravity of cement, that is 3.15. Solving for the answer, that is 0.0922 cubic meters. This is our answer. Letter A. Okay, next number. If the volume of cement, coarse aggregate, and 1.5% entrapped air is equal to 0.65 cubic meters, what or find the weight of the fine aggregates? Okay. Remember, the volume of concrete is made up of volume of cement plus a volume of water plus a volume of coarse aggregates plus a volume of fine aggregates. You multiply this with the percentage of the entrapped air. I will divide this by 100 since this percentage should be in decimal. Now, in the problem, it is stated that the entrapped air only consider the volume of cement and volume of coarse aggregates. Yung fine aggregates na separate siya. Yung water naman, hindi direkta na sinabi sa problem na included dito yung water. But as per analysis, water should go with cement and the coarse aggregate. Yung fine aggregates lang ang hindi included. Therefore, yung formula would look like this. Plus the volume of fine aggregates. Now, this one, all of this is equal to 0.65 cubic meters. So all of this 0.65 0.65 cubic meters. And our volume of concrete, we assumed earlier this is 1 cubic meters. With this, we can now solve for the volume of fine aggregates. 1 cubic meter minus 0.65, that is 0.35 cubic meters. Can we now solve for the weight? Yes. The weight of fine aggregates is simply equal to the volume of fine aggregates multiplied by the unit weight. Weight is equal to 0.35 cubic meters multiplied by unit weight of water multiplied by the specific gravity of the fine aggregates. The answer here is 9.099 kilonewtons. And this is our final answer. Letter A. All right. So that's it for our mixture situation last April 2025. I hope you were able to understand this problem. If you have any comments or suggestions, please feel free to drop a comment in our comment section below. And with that, thank you everyone for watching and like and subscribe for more videos.